and here is a capital D. Okay? And we are talking about any one of the point, some point P. Yeah. This is a point P where you are getting this is the minima, this is the Y. Y is the distance from some nth minima from center of the screen. Okay? And this is the slit. This is the planar wavefront. MN. So path reference here is now path reference is this. This is Q. This is theta. Okay. Now, condition for minima. Right? This is the slit of width A, Mn. Now, for minima, if path difference, what is that is NQ equal to delta X equal to N lambda. Okay, for example, now explanation. If delta X equal to lambda, assuming N equal to 1. So if path difference here is lambda, what is that N lambda? So where N equal, if you take N equal to 1, this is delta X equal to lambda. This delta X equal to lambda. Then what he will do? So divide slit of width A, divide slit of width A into two equal parts. Two equal parts. What is that two equal parts? Here, this is A by 2 and A by 2. This is A by 2, this is A by 2. Okay?
Yes.
Each contributes a path difference of lambda by 2 each. Lambda by 2. And this will contribute lambda by 2, this also contribute lambda by 2. Ante? That is, this is Mn, e point M better point O dash. O dash. So, wavelets coming from M, comma O dash, differed by lambda by 2. What is the path difference between M and O dash? Wavelets coming from M and O dash. Okay. differed by lambda by 2. So whenever path difference coming from M and O dash at the point P is lambda by 2, phase difference is how much? Pi.
Yes.
Phase difference is pi means these two are in what? Opposite direction. So they cancel each other. So these two cancel each other. Similarly, okay, wavelets coming from O dash and N, O dash and N, differed by lambda by 2. They cancel each other. So this is lambda by 2, this is lambda by 2 kada. The wavelets coming from O dash and N also differed by path difference lambda by 2, and these two also cancel each other. So overall at the point P everything is cancel each other, nothing will be there. So thereby point P is minima. Arthavenda? I have explained one case, how it is coming.
But can you move camera to
Up or down?
up? Sir. Sir, can you move the camera downwards?
Vendankar. Okay. Right? Now, next one is, suppose if delta x equal to 2 lambda, n equal to 2, okay, divide the slit.
Excuse me, sir.
Ah,
Sir, if you take the camera a little back, the entire board will be visible.
Yes, so it's not visible.
Not visible, huh?
No, sir.
Yes, sir. At the
Yes,
same
sir.
time, the top and the bottom is not.
Will also be visible. Yeah.
Yes, sir. Now it's just.
అయిందా అడుగు చూరాజు
Yes.
Now, if delta x equal to lambda, n equal to 2, divide the slit of width A into 4 equal parts. 4 equal parts means like this. 4 equal parts. Each is how much? A by 4. Okay. Now each contributes path difference of lambda by 2. This is lambda by 2, this is lambda by 2, this is lambda by 2, this is lambda by 2. Okay. Again, what happens now? So these two will have a path difference lambda by 2. These two will have a lambda by 2. This is lambda by 2. This is lambda by 2. So wavelets coming from M and this is lambda by 2. This and this is lambda by 2. This and this is lambda by 2. This and this is lambda by 2. Again, they all cancel each other. Kada? So wavelets coming from this is M and now A B. Now we divide into 4 parts. See, M A equal O dash B and B N. So wavelets from M comma A. Okay. Wavelets from A comma O dash. Wavelets from O dash comma B. Wavelets from B comma N. Okay. Differ by lambda by 2. Differ by lambda by 2. Differ by lambda. Differ by lambda. And yeah. And cancel each other. How he explained? Whatever he explained, we are copying, that's all. Scientists discovered the idea. What he is doing? Suppose if the path difference is 2 lambda, क्या करे उन्होंने? A पूरा slit जो है, is divided into 4 parts. See, M A and A O dash B, B N is divided into 4 equal parts. And each differed by path difference lambda by 2. So lambda by 2, 4 lambda by 2 is how much? 2 lambda. Again, they all cancel each other, produces 0. Follow? Right?
చిన్న బాక్స్ ఉంది ఆ చిన్న బాక్స్ పట్టణంతో పెట్టు చిన్న బాక్స్
Okay. So, you over top one.
Yes, sir.
So condition for minima is n lambda, where n equals to 1, 2, 3, 4 and so on. Correct? So angular position of nth minima. What is that? Sin theta equal to, delta x by, delta x is how much? N lambda by a. Correct? Right? So, first angular position. Sin theta one is lambda by a. Second angular position is 2 lambda by a. Hello. What is a linear position? Here, and I told, I think this is y. This is also theta. So, tan theta equal to how much? Now, first angular position of minima is tan theta 1 equal to lambda by a. Okay. What is the, this is the first angular position of minima. This is the minima. This is the minima. First angular position at theta 1. So this theta 1 on both the sides, no? On this side also. This is theta 1. So both the sides means what is that? What is the angular width of central maxima? Like, what the phone? Photo notes. Anyway. Now, angular width of central maxima. What is the angular width of central maxima? This is the angular width of central maxima is 2 theta 1. 2 theta 1 ante theta 1 enta lambda by a. 2 theta 1 ante enta sin theta and theta approximately equal kada. 2 lambda by A. This is the angular width of central maxima. By the మొత్తం ఇదంతా central maxima. This is called central maxima. Okay. What is the linear width of central? What is the linear position of the minima? What is the linear position? Linear position of minima. What is the linear position of the minima? Y equals to the n lambda d by A. Kada?
Yes, sir.
నేను రాసిన కదా tan theta equals sin theta అని పెట్టి y equals to delta x equal into d by lambda. Delta x ఎంత n lambda. So linear position of minima is what is the first linear position? First linear position.
Lambda d by.
Y1 is equal to lambda d by A. What is a linear width? Linear width of central maxima. Anta? What is the linear width of central maxima? Delta y. Delta y equal to 2y1. 2y1 enta? 2 lambda d by A. కదా ఇది y1 ఇది కూడా y బై ఇక్కడ నుంచి 2y1 the linear width angular width అంటే ఇది okay linear width of central maxima. Now this d approximately equal to capital F. So delta y equal to lambda f by A. Clear? Right? This is for minima. What about the maxima? For maxima, for maxima, path difference. Delta x equals to 2n plus 1 into lambda by 2. For maxima, path difference how much? 2n plus 1 into lambda by 2. Suppose for n equals to 1 anko. For n equals to 1, what is the delta x you will get?
3 lambda.
By 2. So 3 lambda by 2 ante, even though if we divide if we divide the slit into 3 equal parts. Three equal parts. 3 A by 3, A by 3, A by 3, A by 3. Yes, sir. That's right, that's right. Fine. నువ్వు ఎప్పుడు 7:30కి వస్తుంటావు కదా 7:30కి వచ్చి దాన్ని చేసేస్తే ఈక్వల్ క్రియేట్ for maxima if the path reference is 2n plus 1 into lambda by 2. Suppose n equal to 1, delta x is how much? 3 lambda by 2. Now divide talpayamma Adalakshmi. If we divide, split into 3 equal parts, 3 equal parts cheste emaitadi, this is cancelled by this, okay, and what, this is cancelled by this, but this cannot be cancelled by this is uncancelled. Endukante this is lambda by 2. See, from here and here is coming lambda by 2. Now from here and here already coming lambda by 2. This is already we used. From here and here is lambda by 2. From here and here is lambda by 2. So this is used, this is used. So this is not used. This is uncancelled. We are dividing 3 parts kada. So this is cancelled by this. Similarly, this is also cancelled by this. What about these two? This portion lambda by 2 is not cancelled. So this will appear here. So if we divide the slit into 3 equal parts, 2 parts.
Sir, why are we not taking delta x is 2n minus 1?
2n minus 1 తీసుకున్నాం అనుకో. If you take 2n minus 1, n equal to 1 by 2. ఏమవుతుంది?
Lambda by
n equal to 1 పెడితే ఏమవుతుంది? lambda by 2 అవుతుంది కదా?
yes.
సరే lambda by 2 అవుతుంది. lambda by 2 అయితే ఏమవుతుంది? Entire path difference is lambda by 2. అంటే you will not get maxima here. So this, the path, that is path reference, thus wavelets this and this differed by lambda by 2 అంటే here you will get minima, not maxima. Cancel అయిపోతాయి కదా.
Yes.
Entire path difference lambda by 2 అంటే wavelets coming from this and this, they are getting cancelled here. You will get minima. Okay.
Yes.
So 2n minus 1 is not possible. అందుకోసమే 2n plus 1 అనుకో. n equal to 1 పెడితే ఏమైతే 3 lambda by 2. You divide into 3 equal parts. So this is cancelled by this. So you use itla. Idi. This is cancelled by this. This is cancelled by this. You are not utilizing this portion. So this is this lambda by 2, this lambda by 2 cancelled. Whereas this is not at all used, lambda by 2. So this will appear at the point P as an intensity here. Follow? So if you divide the slit into 3 equal parts, 2 parts of lambda by 2 gets cancel each other, but one more, third part does not cancel, produces what? Maxima. So this produces first maxima. First maxima ఇది first maxima. ఇది second maxima. ఇది third maxima. ఇది first minima. First minima. ఇది second minima. Whatever you are getting this side, same thing you will get this side. Okay, but third part does not cancel. Produces what? First maxima. So what is that? Sin theta is equal to delta x at delta 2n plus 1 into lambda by, this is angular position. So what is a linear position at it? For linear position, y by d equal delta x by a. So for linear position, what is that? Y equal to d by a. Delta x is the 2n plus 1 into lambda by. So y equal to 2n plus 1 lambda d by 2a. So this is a linear position, this is angular position. Okay? So it was ఇక్కడ central maxima surrounded by alternate maxima and minima. Central maxima surrounded by alternate what here? Maxima with a decrease in fringe width. Okay, and with decrease in intensity. Decrease in intensity. Okay. తీయండి అసలు ప్రాబ్లమ్స్ తీయండి. పేజ్ నంబర్ 313. 320 exercise 3.
316, sir.
Hmm. 316 పేజ్ నంబర్. ఓకేనా? తీయండి అందరు పుస్తకం తీయండి తొందరగా, ఫాస్ట్ గా.
Sir, angular width, sir. Angular width.
యాంగులర్
Width.
ఇది లేదు, యాంగులర్ అంటే
एंगुलर विथ डिस्कस नहीं करना सर आप।
యాంగులర్ విడ్త్ ఆఫ్ సెంట్రల్ మాక్సిమం అంటే ఇది డెల్టా టీటా. అది ఆల్రెడీ రాసిన కదా, రబ్ చేసినాం. 2 లాంబ్డా బై రబ్ చేసాం కదా. చూడండి ఫస్ట్ చూడండి క్వశ్చన్ పేజ్ నంబర్ 316. తీయండి అందరూ ఫాస్ట్ గా.
Excuse me, sir.
యా
Sir, resolving power of microscope and telescope we have to do it.
అది కూడా ఉందా?
Yes, sir.
Yes.
ఉందా?
Yes, sir. They've given
Yes,
us
sir.
the diffraction, resolving power of telescope and that of the microscope.
రిటర్నా?
Yes, sir.
దెర్ ఇస్ ఓవరా. అయిపోయింది చూడు.
Yes, sir. Done, sir.
Next, listen. Fresnel distance ZF. Okay. If diffraction due to single slit is equal to width of the slit. Okay. If diffraction of central maxima, due to single slit is equal to width of the slit, then distance between slit and screen, okay, is equals to, okay, Fresnel distance. ZF. Okay. So ఇప్పుడు ఏమంటాడు వాడు? చూడు Okay? Now this is your single slit. This is screen. And this is a planar wavefront. You will find here central maximum. Like this you will observe. Like this. So what is the diffraction of central maximum? This is called diffraction of central maximum. It will be diffracted up to first minima. Color? On both the sides. It diffracted this side by 1, this side also by 1. So y1 minima is equal to A. A ante width of the slit. y1 minima ante చెప్పు ఏంటి? ఇతర y1 minima ఏం రాసాగా? Lambda d కదా? Lambda d by A is equal to A. Here this d we are calling as d and this is the d. Distance between the slit and screen is called d. So here d we are calling as distance between slit and screen is equal to Fresnel distance. And d now equal to ZF. So lambda into ZF by A equal to A. So ZF equal to A square by lambda. So this is called Fresnel distance. Okay now? What is the Fresnel distance? Asara?
Yes. Sir, A width of the slit है ना?
Huh?
A width of the slit
बस
है ना?
यार दिख रहा ना? देखो
हाँ, yes sir.
ये width of slit long back I told you.
नहीं इधर पूछ रहे हो सर.
पूरा होने के बाद वो कहावत है पूरी. Now, so if case 1, if D means this separation, is greater than ZF, D, ZF क्या है? A square by lambda, correct? So lambda D by A square is greater than 1, correct? Huh? 1 greater than A square by lambda D. So 1 is greater means A square by D lambda is less than 1. Hello? A is width of the slit. D is a separation between slit and screen. So do you know A square by D lambda? This is similar with B square by L lambda. मालूम है? B is the size of the slit. Here in the place of B, what is given? A. And D is the distance between the slit and screen. D का place में क्या दिया? L. So this already they have written in the books. B square by L lambda is less than 1. Less than 1 is what? Wave optics. That means wave optics is valid when the separation between slit and screen is more than just if this particular D is greater than ZF. Okay. The separation between these two is greater than Fresnel distance. एक दूर ज्यादा है, then this particular will give wave optics. Wave optics means it obeys, the light obeys the wave pattern and you will get diffraction like this. Okay. Suppose if S2, if D is less than ZF, this D is very small. So D, ZF क्या है? A square by lambda. So D lambda by A square less than 1 or 1 less than A square by lambda D or A square by lambda D is greater than 1. Now this is less than 1, this is greater than 1. Do you know that is D square by L lambda greater than 1. Whenever this A square by D lambda, that is nothing but B square by L lambda greater than 1 means, what is this optics?
Ray optics.
Ray optics. RA by A. So ray optics is valid. Ray optics are the lenses and mirrors. When this distance is less, the same single slit will behave as like a rays, light rays. When this distance is very far, then this behaves like the light behaves as a wave. You will get diffraction. समझ गए ना?
Yes, sir.
So this is with the complete diffraction. Over. Next, coming to the resolution.
Excuse me, sir.
Mirror. Mirror పెడితే mirror duty ఏంది? Reflection అవుతుంది. Whatever that is wave or ray, when you put a mirror here, it gets reflected. You won't get on the screen, on the mirror. After reflection, somewhere you will get. And you will get illumination here. Nothing will be seen. Again, there was మొత్తం ఇక్కడ illumination వస్తుంది. ఇంకేమొస్తుంది ఏం రాదు. Here, this experiment is conducted to see what is the diffraction. Next resolution.
Sir, time हो गया.
Sir, time up, sir.
Time up, huh?
Yes, sir.
So tomorrow resolution as well as
Problem.
Okay.
Okay.
Tomorrow it takes complete resolution. एक period लेता. Okay.
Thank you, sir. Bye. Yes.
Okay, sir.
Thank you, sir.
Bye, sir.
Huh? Problems exercise 2 started in 316 page. Huh? నేనే చేస్తా. మీరు చేయండి. How you are able to do, you do it. Remaining I will do it. What is there?
Saturday करते हैं ना sir.
Thank you, sir.